Okay, the maximum depth of discharge. So we had already seen what is the depth of discharge under the battery terminologies from our previous slides. Depth of discharge is the ratio between the discharged capacity and the available capacity, right? So what do you mean by maximum depth of discharge? So normally for batteries, for the safety of the batteries, we don't drain all the energy from the battery. Okay, so we only obtain uh, up to some energy level. So, so the battery can't be fully drained or below the EODV. So we should not drain the battery below the EODV, and BMS will have a maximum depth of discharge for the prevention of the overdraining. So we can set the BMS to not to drain the battery less than 20%. That is for the safety of the battery. So in that case, let's say we are using 100 ampere hour battery, then only if we set the maximum depth of discharge to 20%, then only 80 ampere hour power energy can be obtained from the battery. So that is the maximum depth of discharge. So the value of maximum depth of discharge changes with battery types and operating conditions. So for different battery types like lithium ion, lead acid, we have different maximum DODs, as well as for different operating conditions, we will have different maximum DODs. Like when we are operating in elevated temperatures, we can't obtain so we this percentage of 20% should be increased for a elevated temperature for more safety of the battery, right? So these values can be obtained from the battery manufacturer. So from their specification we need to find for this temperature or this operating condition, and for this type of battery what is the maximum DOD. So that we will set in the BMS for the safety of the battery system. Okay, so that will affect the total energy requirement from the battery also. So if we are operating it, so in this case, if it is 30%, right? Yeah, normally the maximum depth of discharge is high, right? 80%. So if it is 70%, then you can see instead of 80%, if you use 70% here, this will be increased. So if the maximum depth of discharge is decreased, our total energy requirement from the battery is increased. Then we need to use more capacity battery, right? So that's how the maximum depth of discharge is going to affect the total energy requirement from the battery or the actual battery capacity. Right, now let us move to the days of autonomy, which is another parameter in the previous equation. So the factors that need to be considered when deciding the days of autonomy are the criticality of the application. That means for which application we are using. So how much critical is the appliance, right? If the loss is higher when the system breaks down, we need to the criticality of the application is higher, right? So we need to increase the days of autonomy so that we have a higher capacity of the battery. Okay, and also we need to consider the type of renewable energy. For example, for PV we can obtain power only in days, but for wind we can through the day we can obtain the energy, right? If it is a hybrid, then we can reduce the days of autonomy because anyhow either one will provide the energy, either PV or the wind will provide the energy, so we can reduce the days of autonomy. And also we need to decide the days of autonomy based on whether it is a grid connected or standalone system. So if it is a grid connected system, we don't need much capacity because we have always have a backup of grid, right? In if both these systems, I mean, if grid is failed and also the PV is not PV or wind is not providing energy, only we need the battery system. So in that case, we can reduce the days of autonomy, right? So if it is a standalone system, then we need to increase the days of autonomy. And if there's a backup generator, we can reduce the days of autonomy. And if there's no backup generator, we can increase. And also, if it is a solar PV only system, what is the maximum continuous cloudy day without power production in the particular area? So we need to uh, consider that also. So if the maximum continuous cloudy days is higher in that particular area, we need to go for higher days of autonomy, right? So these are the uh, criterias for deciding on the days of autonomy. So this is solely on the designer's perspective. Okay. And another parameter we have seen in that equation is the system voltage selection. So in this chart, you can see for nominal power of the inverter for particular power values, you can see the voltage, nominal voltage of the battery. Okay, so for up to 1,000 watt or 1 kilowatt systems, sorry, up to 2 kilowatt systems, we can use 12-volt battery, and up to 3.5 kilowatt inverters, we can use 24-volt battery. Okay, higher than that, we can go for 48-volt batteries. And so from this total power, we can decide on the voltage of the battery that should be used. So if let's say according to the power requirement, you need to use a 48-volt battery. Then, but you have in hand the 12-volt batteries. What you can do is you can connect those batteries in a series connection to obtain. You can connect 4 batteries in series, right? And we can obtain 48-volt battery pack, right? So that can be done. And also, if we need to increase the capacity of the battery storage, we can connect batteries in parallel configuration, right? So the watt hour is, let's say the watt hour is less. So you need 100 watt hour, but you have only 50 watt hour batteries, but you have two. Then you can connect it in the parallel configuration and you can deliver it to the system. Okay, so that can be also done. And temperature effects should be also considered. The battery should be operated under the rated operating temperatures. If not, the capacity of the battery reduces, right? So you need to consider that also in the previous, so in this equation. Okay, so that can be given as the efficiency of the battery. So efficiency of the battery reduces when because of the temperature effect. So you can decide on the battery efficiency if you are operating it in a elevated temperature. And another another thing is, let's say you are using the battery in a lower temperature than specified. In that case, you can do this, like you can use the heat from the inverter to heat the battery pack. Okay, so this is mostly suitable for cold countries or cold with let's say the nominal temperature or the specified temperature for operating the battery system is 30 degrees C, but your environmental temperature is 20 degrees C. Then you can use the heat from the inverter to heat up the space that is the battery is assembled. Okay, the battery pack is assembled. So, and also these are some other factors that to be considered while designing a battery energy storage system capacity, or battery energy storage system. So the space requirement of the battery storage system. So how much space does the battery system is going to take, and what are the necessary modifications that are needed in building to install the BESS, and what is your available budget. So based on that also you need to decide on some of the factors, and what are the environmental aspects and limitations. Okay, so this is a cost and performance characteristics of energy storage technologies. So you can refer to this table when so the source is IRENA. And you can refer that source also for this chart. So you can see different type of batteries are given here, and for which capacities we can use both systems, and all those details are given here, lifetime. So this chart can be also used for deciding on which storage system you are going to use. Okay,